Hi everyone, welcome back to the channel. This question was also asked in IIT JEE 2025 this year in Advanced. And this is also a question which involves a little bit of concept and some manipulations with the question. So let's start solving this problem. So it's given that there is a star of mass m2 revolving around the other star of mass m1. So let's draw some picture here. So let's say this is the bigger one, m1, and then there is another smaller one here, m2. And m2 is revolving around this, so it is going in a circle, let's say like this. The distance is given as r, and let's say it has a velocity v tangentially. And the heavier star slowly acquires mass from the lighter star. So m1 starts gathering mass from m2. So what will happen that because m1 is getting bigger and m2 is getting smaller, so the distance will keep reducing. So the r is not constant here. And the heavier mass is acquiring mass at the rate of gamma kg per second. So we need to find out this expression 1 by r dr by dt. Okay. What is conserved here? If you see, there is no external force. So external force is 0 and external torque is also 0. If we have this, then torque is nothing but dl by dt, right? This is 0, this is given. Plus, we also know that at any instant, if this is in a particular orbit of radius r, then the gravitational force should balance the centripetal. Okay, so these are the two things that we can apply. So let's start with the angular momentum. Angular momentum is nothing but, if you see from the m2 perspective, it's given that m1 is big. So we can assume that m1 is not going to move, only m2 is moving. In ideal condition, that's not happen. Both mass moves. But here, let's assume that m1 is not moving. Therefore, the angular momentum is m2 v r. Okay. And then if we do dl by dt, then that should be equal to 0 because the torque is 0. Okay. So let's just do that. Okay. So what is dl by dt here? dl by dt should be equal to dm2 by dt, because m2 is also variable, v into r, plus m2 dv by dt. V is also going to change because r is changing, plus m2 v dr by dt, right? Now this is given that this is 0. Now dm2 by dt, it's already given that it's acquiring a mass with this rate. So let's say gamma vr plus m2 r dv by dt and plus m2 v dr by dt. So let's write this expression in terms of what they want. They want 1 by r dr by dt. So let's take dr by dt and 1 by r. So if we take dr by dt on one side, we're left with minus gamma v r by m2 v, because we need to divide everything by m2 v, and then 1 r is coming also extra, so 1 r, and minus m2 r by m2 v and r, and then dv by dt, right? Okay, so which is equal to vr will cancel out these two, and m2r will also cancel out. So this will be just minus gamma by m2 minus 1 by v dv by dt. This is my expression for dr by dt. Okay, let's just simply box this one. Okay, so this is the equation 1. Let's say call it A. Now, we also know that since it is moving in the orbit, so the force will be balanced here, and that force is nothing but g m1 m2 by r square equal to m2 v square by r. So therefore, what we get is V square equal to G m1 by R. Now let's differentiate this also with respect to time. So we get 2V dV by dt equal to G m1 R square minus dr by dt. Now ideally, I would take m1 also as variable because m1 is also gathering mass, but m1 is really big, so the question is saying that there is no other loss. It's saying that there is no other loss. So basically we can just assume that m1 is so big, even if it's gathering with some rate, we can take it as 0. So we'll just live with this. So therefore is dv by dt equal to minus g m1 by 2v r square dr by dt. Now we know that gm by r is v square. So basically I want to replace the g. So gm1 will become rv square, and 1r is already here. So it will become, and then 1v is also here. So it will become minus v by 2r dr by dt. And therefore, if we take 1 by v dv by dt, this will be minus 1 by 2r dr by dt. So if we box this also and call it b, then we have from a and b 1 by r dr by dt minus gamma by m2 minus 1v by dv by dt. So this we can simply use this one. So plus 1 by 2r dr by dt. So that means if we take this whole thing this side, this will become 1 by 2r dr by dt minus gamma by m2, and therefore 1 by r dr by dt is equal to minus 2 gamma by m2. So this is the answer. The option B is the answer here. So it is not difficult problem. We just use two concepts, that angular momentum is conserved and the force should balance each other. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.